maybe you've seen exponents before. Have we talked about exponents before? Perfect. Well, then you'll be a little smarter today than you ended up yesterday here. Here is the parts of an exponent. This little guy up here, this little tube, is what we call the exponent. It is also known as, aka, if you will, a power. Okay. It is also known as a power. Powers and exponents are the same thing. This big number here is what we call the base. Okay. And here is what you need to write down for this. We'll talk about where most people go wrong on this here. The exponent tells you how many bases get multiplied together. Let me write that down and then we shall talk. A little proverbial turkey here. The exponent tells you how many bases get multiplied together. You definitely want to have some examples written down that I write down here. So let's look at 5 to the second power. This 2 tells me that I am multiplying 2 5s together. Please understand, this is not 10. It's not 2 times 5. Otherwise, I would have written it as a multiplication problem, 2 times 5. It is 5 times 5. The answer to 5 squared, simplified, is 25. 5 to the second power is 25. 5 to the third power is not 15. It is 5 times 5 times 5, which does anybody know what 5 times 5 times 5 would be? 5 times 5 is 25, and 25 times 5, if you have 5 quarters, how much money do you have? Zach? 125. And then, if I had 5 to the fourth power, I don't know why this thing's not working. It's not 20, it's not 5 times 4, it is 4 5s all multiplied together. Which 5 times 5 is 25, and we know times another 5 is 125, so now I gotta take 125 and multiply it by 5. Anybody? 125 times 5? Joseph? Not adding 5, multiplying by 5. 125 times 5. Caleb?
600.
Well, that's 600 is 120 times 5. We're getting closer. Chase?
625.
625. And then, heaven forbid, you do 5 to the fifth power, which is 5 5s times themselves, which gives us all this, except now I got to take 625 and multiply it by 5. Lauren? I think Lauren did that on paper. I'm not so sure she actually did it in her head. Now, what you'll notice, people, and maybe you can see this, that as these exponents get bigger, your numbers get bigger a lot faster. In other words, I went from 5 to the second power to 5 to the fifth power, and this thing went from 25 all the way up to 3,000. And the next one, if I did 5 to the sixth power, it's going to be in the 15,000 range. If I did 5 to the seventh power, it's going to be in the 75,000 range. So if you ever hear the phrase that something grows exponentially, what that means is it starts growing slowly, but then it starts growing really, really fast as you keep going a little bit farther out. Like, you go from 25 to 125, oh wait, so what, it's 100 difference, right? But to go from 125 to 625, that's 500 difference. Now this one I actually went up like 2,500, and the next one would go up, 12,000 bigger and blah, 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 blah. So you have to be very careful with exponents because they get really big really fast. Some other examples would be, if you have, 7 to the third power, which is not 21, it's not 7 times 3, it's 3 7s times themselves. That's a pretty big number, because 7 times 7 is 49, and 49 times 7, somebody out there in the real world, which by the way, you can easily do 50 times 7 is 350, but it's not. Take 1 7 away, and 1 7 short of 350, which is what? Well, 343, yes. Now, when you talk about exponents, we kind of have some special cases here. I'm not so sure the book talks about this, but I'll give it to you now just because. If you have something to the first power, anything to the first power is itself. 7 to the first power is 7. 35 to the first power is just 35. Okay. And then a couple other things to know is we have some other names for second power. Instead of saying the second power, usually, if something's to the second power, we usually call it squared. Usually, instead of saying 7 to the second power, I call this 7 squared. And 7 squared is, 7 times 7 is 49. Just like if it's a 3, I don't usually say 7 to the third power. Do you know what we call things to the third power? If to the second power is squared, to the third power is, instead of saying third power, we say cubed. You just say the word cubed instead. So if I had this, 6 to the third power, you would say this as 6 cubed. And guess what 6 cubed is? Please don't say 18, it's not 6 times 3, it's 6 times 6 times 6, which is 36 times 6. 118 and 36, how about 216, is that right? 216. The third power is cubed, second power is squared. The rest you just say what power it is, like this. This would be 2 to the fifth power. You don't have any special names for 5s or whatever, it's just squares and cubes. 2 to the fifth power, what do we think that is? Clayton?
10.
Don't say 10. It's not 2 times 5, it is 5 2s times themselves. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay. Please get that in your head. It's not these two numbers times themselves, it's that same number times itself a bunch of times. Perfect. Now, unfortunately, we have to talk about a little bit more.